I'm coming back to our class diagram for the animal class to note a couple changes. One is I now have the pound symbol instead of a minus sign. The pound symbol designates that it's a protected class level variable, and we need to change the animal class to reflect that, and also that we have a static double variable for food total. When we're all done, we will come back and double check or look at our animal class diagram again, just to make sure everything's cleaned up. Now we are going to go ahead and exit this mode and get back into Visual Studio, and we are going to finish up our reptile, hopefully. A couple things I did not mention before. When you are creating a subclass, you must pound include the superclass header file. So I didn't mention it, but if we take a look at mammal.h, the first thing was pound pragma once, and then pound include whatever header file for the superclass. So pound include animal.h. And then when we create, in this example, reptile, it's class, the name of the subclass, a colon, and then public animal. This designates the access that you have to animal here. In reptile, we do have one more instance field, and normally you have seen me putting the instance fields at the beginning of a class. It is a practice by our Shazam mentors to put their private instance fields at the bottom of the class, so I want to demo that, and they might mention that, or they might, if they send you some code or you see some of their code, you might see their private instance fields at the bottom of the class definition rather than at the top. And then we have our reptile that we are going to implement now. We have several methods in reptile, and some of these we might decide to that we might not need them. For example, get total food. Maybe that's exactly the same as our superclass method, so we might not need that at the local level. Get info we are going to keep, because remember in mammal, when we did our get info, we did change that a little bit in mammal.cpp. Our get info method was to just designate that it was a mammal. So we're going to want to do something similar like this in a get info method for a reptile. I'm going to copy and paste over some code, and then we will pick up from there. Copying over the code and then running the program is going to show us the same output that we had before. So just a moment here. Reptile.h, we need to pound include. That's the header file. And then we have a local variable temperature that's going to be in my constructor. I'm going to send in the current temperature of the reptile. And so I'm going to assign that to my instance member temperature instance field. And then if I need to change the temperature, I'm going to just increase or decrease. If I want to decrease, I will send in a negative value. If I want to increase, then I will send in a positive value. My get info method is different because I want to designate that it's a reptile instead of a mammal. But then I'm going to call the animal's get info class, but I need to add some additional information for my reptile to indicate that the reptile has a temperature. Last but not least is the feed method, and if I take a look at feeding the reptile, it looks like this is exactly the same code that we have in animal.cpp. If I take a look, feeding an animal is adding to the weight and adding to total food. So if that's the case, I don't need this feed method within reptile. So I am going to delete that because I can call, it should call upon the superclass variable. That means, and again, here's where planning ahead, doing a very good job on those class diagrams will help save some trouble. I don't need to have the feed method. I do need the get info because that was different. Get total food, I don't think I'm using here. So again, I'm going to delete that. And that means I'm going to have to go back and make some changes to my class diagrams. So planning ahead, will save you a lot of headaches and a lot of time. I am going to go ahead and show you the code here for creating a new reptile. Remember that I had a snake named Zim, so I'm going to have a snake, and my snake is going to be a reptile, and it's going to be named, oh wait, my tiger was named Zim. My snake was named Slither. I don't know what the weight was on Sliver. I still have my text files accessible here. Slither started off at 35 pounds. So we're going to go ahead and just use that same information, even though it's in the data file. And then I believe I had a Komodo dragon. And the Komodo dragon was named Komodo. And don't remember what weight. Komodo started off at 180 pounds. I don't have to use the same data, but I'm going to. Now, it doesn't like something I'm doing here. If I hover over the error, it says that reptile is undefined, and you're going to run across this error quite frequently when you're working back and forth with classes and using inheritance. And it does not recognize anything that's a reptile because I did not pound include reptile up here. So I do need to remember to pound include my reptile header file. All header files that users have created are included in the double quotes, and the other pound includes are built-in libraries or libraries that have already been created. So these are user-defined classes that you guys have been working with. And now it should accept this, but it's not. So it says no instance of reptile matches the argument list. And that's because I forgot to include the temperature of my snake. The average temperature of a ball python is around 90 degrees. So I'm going to put 90 degrees in here. And when I Googled to find out the average temperature of a Komodo dragon, it gave me 34 degrees Celsius, which I converted, and that's about 93.2 degrees Fahrenheit, which is what we're working in here. And so about 93.2 degrees. And if I run our code, we'll cross our fingers. I have an error though. I did not push those two new animals onto my vector. So if I go back, I need to do zoo vector, and I'm going to push those on. And we now have used pushback to put those two other animals on. Let's cross our fingers so when I run this code, we've got our output for all the different animals. And there we've got our output. So Enigma 220, Zim 210, Slither is 45. Remember I ran the food method and we fed everything 10 pounds no matter what. And so we've got total consumed food. Our static class variable is totaling. We don't have, however, the Komodo dragon is not using its get info method, because I should also be seeing the temperature show up here. So let's investigate that a little bit and see why the temperature is not showing up. Our temperature is not showing up, and actually neither is our mammal get info. If we take a look, it was supposed to say a mammal is under mammal, and reptile was supposed to say reptile is and the current temperature. But if you notice, that output is only calling upon the output for an animal. And our issue happens to deal with inheritance. So we are actually not using inheritance like we want it to. And the reason for that is if we come back here, each of our animals is an animal. even though I've designated them as mammals and we created a mammal and we had to use a constructor for a reptile, when I push them onto this vector, the vector is treating them as all animals, and so the superclass method is having precedence. What happens is I want to, if it's a mammal, I want it to take care of a mammal, and if it's a reptile, I want it to actually treat it like a reptile and call those individual methods. In order to do that, we have to use something called polymorphism, and that's going to be a topic for either our next video or some future videos, and it might be a topic that we have one of our Shazam mentors also go over with us.